let me start with one very short round of introduction from all of you about what is your company's plan, current portfolio, and the kind of electrolyzer technology that everyone is focusing on. Start with you, Ms. Nikhil. You take this mic. I will write you.
Hello, hope I'm audible.
Yes.
Yeah, so very good morning, one and all. I'm Nikhil. So I represent Eastern Electrolyzer. I'm heading the technology side there. So Eastern, we're about 30 odd years into this in the electrolyzer field, and we have been here even before green hydrogen was conceptualized in India. So we have the benefit of trying and testing various kinds of technologies and a robust idea of the supply chain in India. So we had started off with the unipolar technology, and we have also migrated into the bipolar technology now, specifically to the alkaline side of the world. So we do anything because the market is not standardized, at least as of now. It's not something like solar where you get X number of cells in a module and you have a table and you keep going up. So we really wish to reach there, and I'm pretty sure that hydrogen is growing at a faster rate than solar, at least that's what the tenders say. So we do anything between, say, 5 kilowatt to 5 megawatt in size. We make test benches because what we understand is that a lot of research is happening. A lot of designs are changing. So we make test benches as small as, say, 1 nm cube. And we also go all the way up to make a 5 megawatt stack, which is 1,000 cubic meter. So we are not, we would like to make more of the 5 megawatts. And we also have a small PEM technology, which we have worked with Indian CSIR lab. And it's a small technology, a tabletop technology. And we integrate larger PEMs and SOEC systems. So that's what we basically do. And how we're looking at it, how we want to grow in the market, is that we're indigenizing most of the components made here. That's one way I think we can be sure of the supply chain and going up and modularizing the whole system. Yeah.
Thank you. Mr. Raj.
Thank you, Mathew. Kowtham here from Larsen & Toubro. I am from the subsidiary GreenTech, which has multiple subsidiaries, including L&T Electrolyzers. So I'm responsible for technology partnerships, including in electrolyzers. We have a gigafactory in Hazira, near Surat, which manufactures alkaline electrolyzer technology. We have products from 500 kilowatt, 4 megawatts, and 20 megawatt modules. As you all know, we have won the IOCL tender, which is India's first large-scale tender in India, so which will be made with made-in-India electrolyzers and engineered-in-India plants, so which is very unique in Indian history, coming from government in my previous avatar. This forum is something which I'm very proud of because this is what we envisioned in 2020, that India has strong manufacturing team which creates a hub, a global hub for manufacturing electrolyzers. And seeing the panel here, I'm very hopeful that it will be a reality very soon.
I don't know if you remember, Mr. Kowtham Raj, but when we did our first green hydrogen conference ever, it was a virtual conference. We did it in COVID, and you were actually part of that conference as well, that time representing Niti Aayog.
Okay.
Yes. I'll come to you now.
Yeah, so my name is Shekhar from John Cockerill, just the tabs are little here and there. So John Cockerill is basically an electrolyzer manufacturer. We are based in Belgium, but we have factories in France as well as China. We are in this for more than 30 years. We have more than 1,200 stacks supplied. We are concentrating on large stacks. So 5 megawatt stack is what we will make in India. Right now we are executing about 600 megawatt projects, which will go online by end of next year in India. And we are setting up our electrolyzer manufacturing factory at Kakinada in Andhra Pradesh. I think the rest we will take it up during session. Thank you.
Thank you. Mr. Mayur.
What a wonderful day to talk hydrogen. It is the World Hydrogen and Fuel Cell Day today. It's 1008, so that's the molecular definition for hydrogen. So for us, I think I always say that hydrogen, from being part of the number one molecule in the periodic table, became a purpose of life for me. So that's how I represent myself as part of the hydrogen community. Very happy to be here with all the senior and distinguished people and companies in our industry. We are an Indian startup who decided to do things locally in an indigenized format. We work on some different ideas in terms of, as compared to what other people are doing. We're working on both fuel cells as well as on hydrogen. The idea is to bring decentralized energy to each individual. I always believe that every household, every place, this hotel or even this room should be 100% energy independent. So rather than looking at large megawatt scale projects, we always look at decentralized projects, going as close as possible you can to the customer, so that you reduce your transportation cost, you reduce the pilferage costs, because at some point there also will be a cost to the carbon that is transported. Even if I'm building an electrolyzer, I transport it from place A to place B, and that is going to cost us as well. My company, H2E Power, we are a 16-year-old company, started working in 2009 with an whole idea to bring energy independence to the farmers and to rural India. That's where I belong to a farming family. And we've been continuing to develop solutions, develop products, develop ideas to ensure that we are able to fulfill our vision. We have a manufacturing plant in rural India in a place called Jalgaon, where we are manufacturing AEM electrolyzers. We do solid oxide electrolyzers, and we do fuel cells. And we're not doing alkaline. There are many people whom we can collaborate for alkaline, and we do that as well. But it's again a different genre of work that we're doing, and we'll be happy to interact with all of you and get into this session. Thank you.
Yes.
Hi, good morning, everybody. I'm Anuj Sharma from Wari Group. So just a quick introduction about Wari Group, and then I'll come to what we are doing on the electrolyzer space. Wari Group is an energy transition company with interests in solar module manufacturing. In fact, we are the largest solar module manufacturers in India with capacity of about 15 gigawatt, doing a lot of forward and backward integration. We are coming up with large cell manufacturing. We already have 5 gigawatt cell manufacturing capacity, expanding it to about 15. We are also coming up with very large ingot and wafer manufacturing as well. So clearly a lot of focus on localization of the entire value chain on the solar module side of it. We are one of the largest EPC players. We set up solar farms for any company, whether the modules are from Wari or not, irrespective of that. And a portfolio of over about 7 or 8 gigawatt, with some of the projects already completed, some ongoing. We are also into battery energy storage systems. We are currently setting up a 20 gigawatt hour lithium-ion cell manufacturing facility in India, in Gujarat, which will be operational. The phase 1 will be operational by next year itself. We are also into inverters. We have recently taken stake in one of the transformer manufacturing company. We are also into renewable energy generation as an independent power producer. So we do have portfolio of wind and solar as well. And apart from that, we are also into, now I'm coming onto the green hydrogen side of it. So we are into electrolyzer manufacturing. We are actually coming up with a 1 gigawatt alkaline electrolyzer manufacturing facility in Valsad, Gujarat. This facility will be operational by about February, March 2026. So as we speak, all the construction works are going on, and the manufacturing equipments will start to move in. And this is just a phase 1. Obviously, we have plans for further expansion of this alkaline electrolyzer manufacturing facility, take it to about 3 to 5 gigawatt hour. in future as the demand picks up. We are also we also have plans to get into green ammonia, green methanol manufacturing as well. Now talking specifically on the electrolyzers, obviously at this particular state-of-art facility with all the automated production lines, we will be manufacturing stacks right from, let's say, about 250 kilowatt going up to about 10 megawatt single stacks. And then associated balance of plant, we have the capabilities to do it skid-mounted purification units, even up to about almost about 40 megawatt equivalent. But we can also do the stick-built systems as well. We are going to have a 5 megawatt test bench available at this particular facility, so we can even test the stacks up to 5 megawatt and demonstrate the performances. We also are coming up with a large R&D facility along with the manufacturing facility so that we can continue to work on the improvements in terms of efficiency, both capital as well as the operating efficiency in the electrolyzers, and truly make sure that we achieve a very low cost of green hydrogen. Looking forward to further interactions. Thank you.
Thank you.
Good morning. My name is Sanjeev Sharma and I am from GH2 Solar. Like Mr. Sharma said, that we are also a similar kind of a company which has interest in the complete value chain of the renewables. We have a very strong portfolio of the solar energy that we already that is already operational. Now going forward, we are setting up a manufacturing unit of electrolyzer that would be based on the alkaline technology at Gwalior. Recently, in fact, just 1 month before, we inaugurated the facility and the construction has started. The manufacturing equipments have started coming in. We are also setting up a BESS manufacturing line there. That would be about 5 gigawatt per year. We also have the interest in green hydrogen and green ammonia. For the green hydrogen, we have an allocation of 10,500 tons under the National Green Hydrogen Mission. And we are talking to some of the off-takers to set up a complete plant. Followed by, then we have the interest in the green ammonia as well, wherein we are setting up one plant at Gujarat that would be of 100,000 tons per annum of the green ammonia. Second is about 250,000 tons per annum of the green ammonia, that for which we are still working out the basic details. The site assessments are going on, and we expect to soon start with the production as well and the project working. We already have executed some of the projects in India. One of the notable projects I would say is the VOC port, wherein we have the on-site generation of the green hydrogen, followed by the storage and compression and the dispensing. Similarly, we are entering into the hydrogen refueling stations as well. We already have identified almost 110 locations across India, wherein the next 2 to 3 years we'll be setting up the hydrogen refueling stations. 3 locations, in fact, have reached to a very advanced level, and perhaps by mid of next year, we will see them operational as well. That's it. Yesterday, we had a very wonderful session, and I expect today even to be better. Thank you.
Thank you. I'll start with you only, Mr. Sanjeev Sharma, because we have 2 Mr. Sharma, so I'll say Mr. Sanjeev Sharma and Mr. Anuj Sharma. You've been here since yesterday, and you've been hearing all the discussions, and you're also going for green hydrogen production, etc. Just let me begin with you. Based on whatever we discussed yesterday and what we're also hearing, what is your take on the side scheme? Just the good parts. We'll discuss the challenges, etc. later. What is your take on the side scheme? How does that help, players like yourself?
Well, I would say that the scheme has been formulated quite carefully and considering all the aspects of the complete green hydrogen value chain, because that generally and normally I would say that it has given a great push to the green hydrogen in India. Without, I would say, the side scheme, it would not have been possible to see all of us here. And, so many people taking the interest in the complete value chain of the hydrogen. There are certain shortfalls as well, which I feel, but as you said that we will talk about them later. But the good part is that at every step, in fact, the government of India has tried to club it with some kind of the incentives, which is a real motivation for the manufacturers like us and the others to come into the big space. And yes, I believe that this will really kickstart the industry movement, which already has happened.
Right. Thank you. I'll come to you, Mr. Kowtham Raj, and we'll begin from there then. What is your take? Are the incentives sufficient? The kind of incentives that have been provided under the site scheme, are they sufficient? Are they insufficient?
So if you ask a manufacturer, incentives are never enough, right? So I do think incentives are reasonable for our program. If you talk about electrolyzer manufacturers, I think the capex of setting up an electrolyzer manufacturing facility is not really high compared to batteries or some other high-tech sectors. So the incentives, I think, are reasonable, but more important than the quantum, it's a certainty of policy. If you look at the global policies in the US, in Europe, or in Japan, South Korea, Indian policy has been very stable. And the green energy manufacturing policy has been very similar. If you look at batteries, solar, electrolyzers, they follow the same template. So there is a lot of predictability in the policy. But that being said, it is given, one of the first times it's given to so many players. If you look at the electrolyzer manufacturing incentives, it's given to more than almost 20 players, I think. So it's a game plan of trying to create as many players as possible, and within those players we create some national champions. Compared to batteries, where we give incentives to 3 or 4 players, and that had mixed results, right? So this is a different game plan where you give incentives to many people, but little lower incentives. So we have to wait and see how this pans out.
Right. Mr. Shekhar, do you agree with what he said? Do you think the incentives are reasonable, or do you think there is definitely scope for more? Or are you looking for more?
I think site is a great scheme. First is it gives visibility. You know, the top 2 industrial houses in India are setting up electrolyzer plant, whereas the electrolyzer market today is 0. So that kind of visibility it gives. And I agree with Kowtham that this time it is distributed well. Of course, we understand as a manufacturer, we have to be competitive, then only customer will buy our product, you know, the value. Incentive does help to kind of bring the investment to India. So I can tell you that we are setting up facility in US. The US facility we acquired about a year back, but India facility is already ahead, because we are thinking that, yes, how can we catch those incentives, you know. So I think site is a great scheme. Yes, there will be challenges. I think one must understand, because these are production linked incentives, right? And there is nobody assuring the market. Many places in Europe, other places, the schemes are little different. Once you invest, you get something back. Here it is not. Only when I find my customer, I convince the customer that my product is the best product, they buy, then against those, you know, guidelines. So I think government has done very well with the limited amount of resources available, that this is not a free money available to anybody. It is only after, it's like an incentive, it's really that incentive, you know, that after doing my round work, becoming competitive, yeah, it's about, you can say 7-8% benefit to the end customer, you know. It's good one to start with.
Right. Thank you. I'll come to you, Mr. Mayur. Mr. Mayur, a slightly different question for you. When everyone is talking about alkaline, and you are the one focusing on, you know, different kind of a technology, what sort of drove you towards that?
A couple of things. One, if you look at electrolyzer space, you know, there is no one size fit all. So it's not that alkaline is the magic wand and it will solve all the problems that the planet faces. Every industry has its own typical nature, and every site, every geography has its own typicality. So alkaline, like I said in my opening remarks, I always knew that if I have a need for alkaline, I'm going to get at least 20 people here and about 118 in China. Some of in China may even give it for free, or they'll pay money for me to buy them. You know, that's where the alkaline market is going. So alkaline is a done story. But if you want to make something better, or you want to try and get the best of both the worlds, and that's how we got into this AEM technology, because looking at applications starting all the way from 1 kg per day to going to about a few tons per day, it made a lot of sense, the AEM technology. PEM I did not look at because of the whole platinum story, and I don't make platinum in India. If platinum becomes cheap, it will be bad news for a lot of women around. If we don't look at platinum. Therefore, AEM and solid oxide as a technology, as the name says, solid. It is a solid technology, and solid in the literal sense, because this is one technology which has the highest efficiency. So if you look at alkaline, none of us sitting here will ever say that alkaline can go below 50 on a system level per kg of hydrogen. On our smallest system that I've built in India, the first one that we built, we've achieved 41 kWh system level, and that's a 20 kilowatt system. A bigger system we have built, we've achieved 37, stack level 28, 29. So it's very aggressive. It has its own pitfalls, but if you're able to run it 24/7, so that's one of the advantage with the solid oxide technology. The other advantage and the greater focus that I have, surprisingly, is not really hydrogen. It is going beyond hydrogen. So we go to process industry, we do co-electrolysis, which solid oxide can do, and we're able to produce syngas. So on a pilot scale, CO2 to syngas, we've proven at about 93% efficiency, from syngas to FT liquids and then methanol and SAF. So that's the path that we're also trying to take. So look at the hard to abate industries. Wherever there is carbon there, how can we utilize that carbon? So see, for me as a company and also as an individual, the focus is how do I reduce imports, number one. How do I decarbonize, number two. Whether it is hydrogen, whether it is something else tomorrow, I really don't care about it. Technology agnostic in that sense. But those are the focus areas. So therefore, look at technologies which can solve this. So you bring in a bouquet of technologies, and then these technologies also reverse into making of a fuel cell, which kind of takes things to the end mile, the last mile.
I'll come to you, Mr. Anuj Sharma. Mr. Sharma, your company is obviously in solar manufacturing and is now moving in electrolyzer manufacturing as well. So when you look at the kind of incentives available in solar versus the kind of incentives that are available in electrolyzer manufacturing, are you satisfied with?
So my views with respect to the incentives on the entire green hydrogen space, electrolyzers or even production of green hydrogen or the derivatives. First and foremost, I would say is this particular production-linked incentives has really catalyzed the whole industry itself. If you look at today, let's say 2 years back, there were hardly any manufacturers for electrolyzers. Today, at least about 10 or 15 electrolyzer manufacturers are coming up in India. They're setting up manufacturing shops. So what it is going to do is it's going to enhance the competitiveness of the entire industry in India. Not only to serve India, but to serve the global demand as well. That's one. If you also look at the spread of these incentives, it is not just electrolyzer focused, but also on the green hydrogen and derivative production as well. And if you look at the recent SECI tenders, where again these incentives are in play, you do see a good cost points emerging from there. Okay. Now obviously these are very, very competitive cost points, and we need to see how this whole thing pans out. But clearly it has created a big euphoria in India, given the low cost of renewables in India, a good skill set, engineering skill set available, be it in terms of hydrogen production or ammonia production or the other derivatives of hydrogen production. We do have a very good skill set available in India, be it from a licensor, technology licensor front, be it from a operations front. We do have that available. And now this is getting moved towards the green hydrogen, green ammonia, green methanol production. So overall, I think a fantastic scheme. In terms of the quantum of money, certainly it could have been more. And this is to kickstart the industry, because at these initial phases, you do require support, for the industry to evolve, become more matured, and then it can sustain on its own. So certainly it could have been more. I would say a lot more needs to be done, particularly on the research and development side of it, so that we can also innovate, improve, and bring the cost of green hydrogen low, and thereby achieve, our decarbonization goals.
Right. Thank you. Mr. Mathew, you've been sitting very patiently and hearing your co-panelists' remarks. So let me ask you the same question slightly differently. Solar manufacturing subsidies came very late than, what we required. Obviously, we required them like 10 years back, and they came very late. So are you, now that the electrolyzer subsidies came quite early on compared to where the market was, are you for the moment, happy with how the policy framework has shaped up in the country?
Yeah, I couldn't be happier that it has come. Generally, the tenders for the demand come early, and the production side comes when the market is already kind of established. And then we have a lot of inflow from our friendly neighbors. So that's what generally happens. And if you see earlier in 2008 to 9, the cost per unit of electricity from solar was at least 10 times what it is today. And now solar is the cheapest form of electricity, and green hydrogen is a concept which we can think of. So there has been a huge reduction in cost and a lot of R&D happening. But now the Indians are also manufacturing similar quality or better of at least the modules happening in India. And most of the cost reduction is happening with backward integration. That is from your ingot, as Anuj sir said, from the ingot all the way to your module. So that's where you are able to actually match another country and make your supply chain robust. So if you're able to do that from, say, day one on the hydrogen side of the world, I think we can achieve backward integration much faster. And the other thing is that solar as a technology is a little more tricky. At least the alkaline is simpler than solid oxide or PEM. And we have a lot of the resources available in India because we don't use any PGMs. Plus it's a 100-year technology. We have been here for a really long time. And it's a tried and tested technology. It has been in the megawatt scale. So the idea is now to reduce the power consumption and make it more. The technology is tried and tested. We have to make it as efficient and as cost effective as possible. So the challenge is, if we start to indigenize it from day one, that helps us bridge the cost gap much faster. And the other part about how beautifully or well worded the policy is, that it gives you, say, about 7 to 10%, depending on the size of your stack. Plus, they assure that you have to reach a very, very low power consumption, because it's a competitive bid. Everybody has quoted pretty ambitiously. And so if you don't quote ambitiously, you don't get it. And once you quote ambitiously, you have to prove it. And once you prove it, it also helps you with the downstream processes. That is, if ammonia has to be sold at what price it is in the tender at the moment, at least 600 or what per ton. So then the electrolyzers are going to be the hydrogen, the renewable energy consumption has to be so much less. The other part, they're also capping your local value addition. So with that, what I would think is further we would need to have some incentives given specifically on, say, electrode manufacturing. Because electrodes and diaphragms are your secret sauce, and they kind of build a lot of your power consumption, and they're very difficult to manufacture and be competitive. So if you could have something in that direction. And the third very beautiful way of putting it is they have asked for at least 60,000 hours of warranty. So you have to make something which is cost effective. It has to consume less power, and it has to last for a really long time. So that way it is well worded. So that really gives you definitive targets to achieve, wherein you can't compromise on cost, quality, or robustness. Plus, so this, I feel this incentive program has given a good way forward for us to capitalize. Yeah.
Right. The next round of questions, I can start with Mr. Shekhar. Mr. Shekhar, since yesterday we've been hearing so much about how there's a lack of domestic demand for green hydrogen. I mean, the government has been trying to build demand, and that the recent auctions have been quite successful. But as such, the demand and there's offtake is obviously concerned. So in that sort of an environment and hearing everyone's plans and the kind of capacity coming up, do you think that immediately, or that in the next few years, once your plants are up and running, there's going to be some bit of a oversupply in domestic markets? I mean, everyone has 1 gigawatt plus capacities coming up, and the projects have not yet reached FID stage for green hydrogen, green ammonia production at least. So do you think there's any concern on that side?
Absolutely, yes. So certainly yes, because like Nikhil mentioned, these site scheme has come ahead of the demand, right? So right now you can say about 10 to 12 gigawatt of capacity is getting ready by say 22 gigawatt, yeah. And if you see the tenders that have come, right, they are about 900 megawatt, right? And I'm sure these initial rounds of tenders, I'm not expecting everything to be bought from India, because still everybody has to meet financially, justify the project, everything. So certainly, yes, there is going to be overcapacity. Globally already, there is overcapacity, right? And we have manufacturing facilities at 4 destinations. We can see we are not able to cross 20-25%, So yes, it is there. And I think demand is what needs to be done as next step rather than any incentives, because, for a larger companies here, probably there is a cash pool, there is some other business which supports this business. But when we go to next level, let's say my bipolar plate, right, where somebody has to invest in a nickel plating facility. We require a 2-meter diameter facility, which are not there today in India. The automobile applications are smaller ones. So certainly that vendor is looking, okay, where is the order coming? So I would say demand is a challenge, and I am sure ministry is working on it. We are in touch with them. I think one of the things Nikhil mentioned, good part here is there is a review every month taken by ministry of all the PLI winners, wherein we are able to exchange what's happening. And fertilizer, with this discovery, more tenders are planned. I'm sure it was discussed yesterday, right? As well as if you hear the Ministry of Oil, they are also aggressively looking at tendering. So demand is, everybody is looking at demand here.
Right. Mr. Anuj Sharma, I'll come to you next. So as you are planning your facility, which is coming up, so are you also looking at exporting? Now that there are obviously demand concerns in India, when you're are export part of your plans, exporting electrolyzers?
I would say sure, we'll be looking at export markets as well. But obviously we are looking at, initially supplying in India and then capturing even the export markets as well. So short answer is that. I think in terms of demand, if you look at, some of the refinery tenders which have already got concluded or are under the finalization stage, that itself is close to about 400, 500 megawatt kind of a demand. The recent SECI tenders which have got concluded and these facilities need to come up, let's say in next 3 years' time, you are talking about a demand of anywhere in the range of about 800 megawatt to about a gigawatt. And what we certainly know of based on the discussions with the MNRE and even the Petroleum Ministry as well, that the refineries are going to come up with further tenders, I would say at least of about 100 KTPA or so, which is going to be, again, a demand of close to about a gigawatt or so. So I think demand clearly is building up in India. And the question is that how are the electrolyzer manufacturers gearing up, to meet that particular demand and also defend from the foreign competition as well. So I think at this point of time, I would say, we are clearly focused in bringing the most competitive solution for the green hydrogen and its derivative producers. That's what our key focus is. How do we really customize the offering? How do we really optimize the offerings? How do we ensure that they are getting the lowest levelized cost of hydrogen? And for that, we are not just looking at manufacturing the electrolyzers, but we are also looking at how do we integrate it with the renewable energy? What kind of advanced controls do we bring in so that the electrolyzers can really respond very dynamically to the renewable energy fluctuations? Putting in the renewable energy profiles and looking at what should be the most optimized sizing of the electrolyzers, building on all of those tools, to help achieve the lowest possible cost of green hydrogen. That's what our focus is at this point of time.
Right,
Thank you.
Right. I'll come to you, Mr. Mayur. Mr. Mayur, you spoke initially about the kind of projects that you're looking at are more decentralized in nature, are smaller than these 100,000 tons, etc. kind of projects. So what is the demand like in that kind of a market?
Demand is quite significant, as a matter of fact. If you really look at going to the doorstep of the customer, that may not translate into hundreds and thousands of megawatts or even gigawatt, but it is, if you really look at the pain point areas in the country or pain point areas in the industry, that is where you need to go. So it's, I'm working on a particular project with the agriculture industry. If you just look at agriculture, and if I just go to the doorstep of every sugar factory or every farmer there in the agriculture value chain, and I'm talking about progressive farmers. So, you have 118 million registered farmers, out of which about 80 million are progressive farmers. Remaining are, their watershed or whatever. So going to their doorstep, providing them the energy independence, if I just take, and we've been talking to the government on this, if you just take that as an industry, and if that industry has to get decarbonized 100% with hydrogen or derivatives of hydrogen, we are looking at 192 gigawatt of demand that will come. Okay, so we are looking at something really, really big. And those demand is always going to be 500 kg per day, or it's going to be 200 kg per day. Go as close as possible. And with hydrogen, like they say that hydrogen is its own enemy. So, the nature of hydrogen, just to transport hydrogen, to store hydrogen, is in itself, it's a challenge. And then today what we are doing, most of the industries, L&T, of course, they'll be setting up a plant closer to the Panipat refinery or whoever have got it. But today I call that the Jawahar Rozgar Yojana of hydrogen. That's what we are doing. Most of us guys are only working for either the rectifier company to make money, or the compressor company to make money, or the storage guys to make money. I'm not working for electrolyzer, definitely not working for my family. So that's how the industry is today. And if I have to get rid of this, then I have to go distributed. I have to go decentralized. There are customers, you go to a refinery, the refinery picks up hydrogen at 2 bar pressure. I produce at 30 bar pressure. I use a compressor to compress it at 200 bar pressure, transport it there, and then again I step it down to 3 bar pressure. Why in the world am I doing that? So that's what gave an rise to that idea that why don't we go decentralized? Why don't I go as close as possible? We are exploring doing pipelines of hydrogen, where we go directly to the customer through a pipe and eliminate the capex. All of us here will agree, the compressor, storage, the capex is more than the capex of the electrolyzer. Electrolyzer is a very docile character in this whole play. Not very expensive, typical workhorse. Does not have a tantrum like what a compressor would have, or what the storage guys would have. They take 10 days to only give a quotation, or 50 days to give a quotation. So that's why the decentralized route is what we have taken. And then we are going as close as possible and trying to develop new markets. See, one expectation is from the government is to develop the market or give us the market. But then what all is the government going to do? I call it the 2G phenomena. God and government, they are all too busy with doing a lot of different things. So let us find out the customer. Let us go to the customer. And we've been, we found at least 7 of such customers so far. We're setting up plants. And we've taken up a very unique challenge based on these green ammonia tenders that came up. We were amongst, including Wari, we were amongst the people who didn't get the tender. We bid for it. So losing the tender was actually very good for us. And we took up the challenge, and I think by end of next year, we should produce green ammonia production cost of 38 rupees. So, necessity always creates...
38 rupees per kg.
Yes, 38 rupees per kg, production cost.
Okay.
So these are things which I believe we can achieve when we go small rather than go big. That less is always more is how I think about it.
Right. Thank you. Mr. Sanjeev Sharma, I'll come to you next. You have one green hydrogen production project coming up, you mentioned, and one green ammonia production. So for both of these projects, are you using indigenous electrolyzers or are you importing? If you can share.
Of course, we will not be importing. While I would say the moment you asked me right in the beginning about the site scheme, the only gap that I feel is the time mismatch. Because most of these SECI projects that have been awarded, in fact, if you see, the teams really need to start working on them. In case if they have to deliver the projects well in time and start with the production, they really need to start today. The problem here is that, in fact, while the government has, incentivized the electrolyzer manufacturing as well, but everything takes its own time. Now, once we started working on the ground in terms of setting up the production facility, now I understand very well that it is going to be at least 1.5 to 2 years before the first production will roll out. So now, but it's a very difficult kind of the situation that we do not want to go for the imports. And of course, when you are talking about the imports, it is again our friendly neighbor, which we don't want to promote. But on the other hand, with all the other, I would say, European manufacturer, the cost is a very, very limiting factor. So we still haven't decided what to do. But yes, most likely we would be using our own manufacturers only, Indian make, and most likely our own make. But yes, a lot of, I would say, different kind of the working is required in terms of the complete design and the engineering, detailed engineering, and which will be number-based only. That's how we are going to do it.
Right. Mr. Mathew, if you can shed some light on what is the industry or the market like in India right now for electrolyzers? How much are we importing? From which major markets are we importing? And do we have enough indigenization of supply chains right now?
Okay, so this is a very size-based game because we have, Eastern as a company, we've been here for more than 3 decades. So we were not really depending on the larger tenders. I mean, for a small company, we've got about 30 megawatt in incentives. So we are not there trying to attack the gigawatt level. So we have been really working on the thermal power plants. So every thermal power plant, you have a electrolyzer, a green hydrogen. I wouldn't say green in a thermal power plant. You would have a hydrogen production station, and so that has been a very steady state of a steady kind of a demand. So there you have electrolyzers, say 100 kilowatt, say 200 kilowatt. Say if you put it in the megawatt, say 0.2 megawatt. It sounds better that way. So that kind of demand. So what we are doing is, if you look at the incentive scheme, we talk about local value addition, which is all the way out there till your final product on the hydrogen, not considering your compressors and the downstream refineries or whatever comes with that. So on a smaller scale, say about 100 kilowatt or 200 kilowatt, the electrolyzer itself is less than, say, 15% of the total cost. And if you compare India as a country with our neighbor, we are 2 of the largest steel manufacturers in the world. We come second, and we are still only 10% of what they manufacture. But the good part is that the costs are very competitive. So if you look at, we are making alkaline with carbon steel, coating it with nickel, similar to what Shekhar sir said. So carbon steel is more or less, say, 2 to 3% difference in cost. So that way we can make all the carbon steel components we want right here in India. And for a smaller stack, that really takes up a large part of the total order value. In some things, I really quote this as a Subway sandwich. Making an electrolyzer is like putting a Subway sandwich together. If you have a premium customer, he's like, I want lettuce, I want this and that and whatnot. Then we have to get premium stuff from Europe, or say super premium stuff from, say, the US, or from really good stuff what the Chinese friends make. So in those cases, we have to, the LVA component doesn't really make much sense. It goes into, the specific energy consumption becomes very high, very, very good, very low in that case. Otherwise, if it all depends on a project. So we are very much capable of making tie rods and washers and disc springs and end plates and all that. So that way, to a large extent, say even up to diameters about 1.5 or 1.6 meters, we have a very robust supply chain in India. But as Shekhar sir said again, is that the plating is something on a larger scale is a challenge. Then when you go for larger scale diameters, maintaining the tolerances and all that requires a lot of skill. So it's not a job shop anymore. It's a special purpose machine. So to a certain extent, we can easily hit close to 95% on the whole project without really having much of an issue on that. But when you go large, the other issue which I feel is that, we are talking about very ambitious power consumptions. And the kind of investment going into these projects is really big. And how many plants do we have which are operating at that low power consumption and have been operating for a while, that we are sure that the bottom line looks good? So I think China has a few plants, but we know they're not performing up to the mark. So that is an area of concern, which I think would be the case. So coming back to your part, I think on a smaller scale, other than a few components, most of it can easily be done in India. Yeah.
Mr. Raj, do you agree with what he's just said? And what are your thoughts on supply chain localization for the kind of electrolyzers that you make?
Okay. I agree with them. I think I will go even more. For L&T, we are working on this for the last 4 years. Yeah, the first thing that we did when I joined L&T in 2021 is to set up a lab in IIT Bombay to build a kind of team. We have 3T concept: team, technology, and testing. So we have one of the most extensive testing capabilities in the world for electrolyzers. Because of that, Indian supply chain is capable of making any coatings: nickel, nickel molybdenum, a lot of combination of alloys. If you can test them and give them the right feedback, they can make anything. They make satellite components for us. They make our electrolyzer factory and R&D lab is located in the same facility as our power turbine manufacturing facility, which is with Mitsubishi. It has extensive material capabilities in terms of multi-million-dollar material testing. And then we built a lot of electrochemical testing, like hundreds of small test stations, large megawatt scale stations, 200 kilowatt, 500 kilowatt. Because of this testing capabilities that we built and strong teams that we built, and the Indian supply chain has surprised us. They have over-delivered in terms of time. All components of L&T electrolyzers are made in India, except the diaphragm, which essentially only few companies in the world makes. Everything else is made in India. Not only for now, even the future components, we are very confident that it will be made in India. And on top of that, we also made our own components, like our own electrodes, our own designs. Our teams are building multiple different combinations for the next generation. So I don't think, unlike batteries, unlike some solar panels like ingots and some stuff, it is possible for India to build a competitive supply chain. But for that, everybody needs to come together and support the supply chain because they have cash flow problems. We are relatively larger companies. We can support them, we can help them, and nurture them. And definitely we can be, I was in Europe last couple of weeks, in IEA, in the European Union, in Brussels. The discussion in electrolyzers is always between expensive European make and cheap Chinese make. I told them that there's a third option, which is India. There are so many companies in India which are trying to make electrolyzers. We already make, Eastern makes for, 30 years. But the world is not really looking at India as an electrolyzer destination or a supply hub. Maybe in 2 years, I think the team here in this panel would change the story. I think we have also a brand problem to talk about. But the supply chain, I truly believe it's not a problem, at least for alkaline.
Right. Mr. Shekhar, hearing what he just said, and since John Cockerill operates in different markets of the world, where do you see India, or the company sees India as in their scheme of things? I mean, how important is India as a market for them?
Yeah, so I agree with Nikhil and Gautam that if you ask, can it be done in India? The answer is yes. So this is only first level. The next level is the volumes. If you were to make only 10 cars in India, you won't have a tire factory because 10 car will require 4 into 10. So that is currently the situation for some items like membrane or diaphragm, that the volume is so low that you can't even put a simple machine which probably, coats the base material with certain catalyst. Even for that machine won't be running for more than 3 hours in a full year. So this is the volume related. So we have to be patient, we have to be patient to match both of these. And I think India has great experience of doing it in automobiles, where we started with certain things imported. And of course, not just automobile, everything else. So the question, can India make it? Certainly yes. There are machine shops which, like Nikhil mentioned, they can achieve the accuracy, the micron level of finish, the adherence to, of the nickel coating, all that is done. Electrodes, diaphragms and electrodes are the two items which are next, cost level in terms of the overall component basis. So certainly, yes, it's possible. The other challenge is when we are now supplying this 600 megawatt, okay, my customer is saying, please provide me something that you have in running for 5 years, right? So then I need to go back to my supply chain to see that the one which is having a tested feedback. So right now we have 6 test benches, in our company, just testing the electrodes and diaphragms, because these are the 2 key components. How do we do accelerated testing so that we do get experience of 5 years of so-called simulated working with maybe a 1 month or 2 month testing period, So the supply chain development is on, and I will just comment on the cost point. Yes, we can be very close to what is, the lower cost talk today. India has proven it in various fields, including the supercritical power plants, subcritical power plants, right? Here, many of our electrolyzers work under pressure, so there is a pressurized alkaline as well. So when it works under pressure, there are standards like ASME equivalent. India is building our own standards, which are going to be released next week. So I'm sure we will be able to offer. We have to be patient because today the demand is less. We are in maybe 2002, 2003 period of solar, where very less action, and the conventional players are looking at it as a very costly and probably too futuristic technology. I would say we are doing well. I just hope that we have this team, because there is going to be a tough period of many electrolyzer makers, but not sufficient market. How do we navigate that? Sometimes we are working on a supply chain coordination, where there is one end supplier. He supplies to 4 or 5 us, because the tenders are going to come to either one of us, not everybody. But that supplier will still get the job, of some plating or whatever. So all of that is, we are working to make this as a success. Thanks.
And so, if you can give us an idea of the current cost of alkaline electrolyzers, if you can even give a ballpark number, and where do you expect that will be in the next 1 or 2 years?
So I think very, very important question, and I would say what Nikhil said is very important, that customers are not just saying, give me electrolyzer, 5 megawatt. The customers are saying, okay, what is the type of diaphragm you are going to supply? Customers are having a choice in selection of that. Sometimes the customer are okay with accelerated testing diaphragm, right? But sometimes they are saying, no, I must need something which is more reliable, because finally some bank is funding this project, right? As you mentioned, the payback of this capex is not 1 year, 2 year, is probably 20 years, right? So the reliability is something that is checked. So when you do all this, right, the cost starts building up from the so-called numbers that are free to specify. If everything is free for me to specify, $400 per kilowatt, possible, right? But if you want, the word, the elephant is, say, zircon, right? Yes, it can vary. The question is, yes, somebody has to take risk, and I really appreciate the developers who have taken the risk to, put those numbers in these tenders. There will be some, tough time, but I'm sure the next tenders which would come up, they may not go up. I only see them going down, So industry will work together to kind of meet those numbers.
Right, thank you. Mr. Sanjeev Sharma, I'll come to you because he sort of gave an indication. But what is your take, moving a bit away from the discussion, but what is your take on the kind of tariffs that were discovered in the recent green ammonia auctions?
See, my first reaction was perhaps on the first, I would say, announcement, it was kind of a wow reaction. Wow, what a discovery we have made. But yes, reaching on to the, I would say, the 8th or 9th or 10th auction, I was a little scared, because the way the things were going and the way they have gone ahead with the pricing in terms of, the range is 50 rupees, which amounts to almost 600 tons per. And that was, I would say, a kind of a surprise for not for the Indian market, but for the entire world. And people were speechless that Now, the main, I would say, the concern area or the cautionary note here would be that these are the folk projects, first of a kind project, at least for India. We haven't built such projects in large numbers to this scale. While the things look very, very easy on the papers when we work on the Excel numbers and, everything fits together, everything is very, very perfectly. But on the ground, I would definitely say that all the people sitting here, they know that what kind of a beast hydrogen is. Yes, we all see on the numbers that things will work out this way, but on the ground, in reality, it works at a very, very different level. I think Kowtham mentioned that in fact, I know one of the Chinese projects which has almost 260 megawatt of the electrolyzers installed there. And the project is one of the biggest right now in operations. It is not performing. It is performing to the 30% of the efficiency of the capacity factor. So there are certain challenges because as I shared that on the papers, everything looks fine. But when we have to convert these numbers into the reality, then the atmosphere is altogether different. So I would be cautious in terms of, in terms of the numbers which all the bidders have quoted. And not all the people, I would say, Kowtham, are like L&T. L&T has, a vast pool of the talent and the resources and manpower as well, besides having the very deep pockets. But some of the bidders in these 13 auctions, they are not as big as anyone else. They are doing this for the first time with very, very limited kind of the resources. Manpower, again, is going to be the critical factors. Even for the operation maintenance, jobs, we do not have very, very highly experienced people who have worked on these kind of the projects for a longer time. So initially, for some time, it is going to be hit and trial methods. People would learn. The players would learn from their own mistakes, and these mistakes can be really costly. They are not going to be very, very cheap. They can be really costly, making or breaking an entire project or making or breaking an entire organization as well.
Okay. I'll come to you, Mr. Mayur. Can you give us a sense on the costs of some of the technologies that you work with?
Sure, we are still very expensive. But I think what fellow panelists have rightly said, that it is always what you want to bid for. So do you want to bid for a tender where you want to become L1? Then you go to China. Simple. I mean, I'm an electrolyzer manufacturer. Sorry to say that, but any tender that I win as a L1 tender, I do not make it myself. Because that's how it is. But if you want to do a project where you're looking at a 20-year perspective, you're looking at a project to last long. So, you're not looking at the initial capex. You're looking at the overall operating side, and you're looking at how much money you're going to make at the end of the day, how low it is going to be on maintenance, what is going to be your O&M costs and all of that. Then the cost marginally goes up, what Shekhar also rightly said. If you're looking at the alkaline and the solid oxide technologies, solid oxide is, it's not even the elephant. It is much bigger than that in terms of the cost today. We are much higher, but the potential to bring down the cost on both these technologies that I said, AEM and solid oxide, is very, very high because naturally speaking, almost 80-85% of the components on the stack can be made in India, or rather are being made in India. Like if you look at solid oxide, out of the 5 things we need in the stack, already 3 we are making it in India, including chemistry. We've gone all the way backwards into changing the chemistry. If the chemistry, the metal is not available in India, we've changed the chemistry. We're able to do that. So the cost will surprisingly come down, and I see the cost for alkaline to be very close to AEM to be very close to alkaline. Maybe even better in some instances, if you're looking at mid-sized plants, if not the very large plants. And solid oxide will always remain a little more expensive. I think that's the price you pay for the efficiencies that you get. So you're looking at, 2 times the efficiency around. So that's how they will be. But if on a project, if you look at the end cost of hydrogen, end cost of the molecule, end cost of ammonia, for instance, what he was rightly saying, and you mentioned about the ammonia tenders. When I saw the prices, I said, thank God, I've not won it. That's what my inference was. But all of these costs will be in the range of, if you look at 2030 scenario, and I say 2030 because today it's not really a commercial scenario. So if he says 400, you can't supply 400 because the numbers are small. But we all will be in the range of 400 to 700. Somewhere in there is where all of these technologies will be.
Okay. Before we go to audience questions, Mr. Anuj Sharma, based on whatever was just discussed, if you can summarize or give us your insights on cost, on supply chain indigenization, and bringing the costs of electrolyzers down.
Long question.
But a short answer.
Yes, I will try to be. So I think a lot of work has been happening on indigenization and enhancing the local value addition. I'm quite confident, having worked in terms of indigenization, that close to about 80% of the overall cost can be localized. Yes, we do have challenges with respect to diaphragms, membranes and all of that, which needs to be imported. But good news is, some of these membrane suppliers are willing to come and set up shops in India to do some amount of activity in India, while it will still be imported, but at least some kind of a cutting can be done in India and then supplied to the electrolyzer manufacturers based on whatever their requirements are. From a catalyst coating point of view, the catalyst coating suppliers are willing to set up shops in India so that they can coat the electrodes. So these are all very positive things, I would say, and slowly and steadily over next few years, we should be in a position to make these electrolyzers 100% local as well. And there are a lot of vendors even sitting in this room, they build different kind of components for the electrolyzers. They've been working hand in hand with the electrolyzer manufacturers to bring in a good quality product. So I think a lot of work happening on the localization, I would say. In terms of cost, I think as the economies of scale gets achieved and the demand gets created more and more, I think we should be in a position to compete with some of the imported products as well. Okay, and it's not just about the initial capex. It is also extremely important is how do you provide this service on an ongoing basis, because this is not a one-time sale. These products are going to last for about 20 years. The stack needs to be serviced. People who are importing, let's say, the electrolyzer stacks from China or anywhere else, they also need to think about what am I going to do after about 7-8 years when the degradation has happened and I need to refurbish this stack. Are you going to completely import it at that particular point of time again, or are you going to get it refurbished in India? What happens if the technology has already advanced at that particular point of time, how it is going to be integrated with the existing balance of plant? All of those things needs to be looked at. Any kind of issues, services or spare parts, how are they going to be available? All of those things needs to be looked into. So people need to look at the life cycle cost and not just at the initial capex itself. That's my submission to all the developers. The other thing to look at is, we see, very aggressive numbers being quoted, and they actually become the headline. Many a times you read these $300, $400 kind of a number, but it could be only a few things are being supplied. Okay. So for example, I'm just stating, people could quote a particular number, but they are not obviously, the rectifier. What kind of rectifier is it? Is it thyristorized rectifier? Is it IGBT? how it is going to perform under the renewable energy scenario. All of those things needs to be looked at. People may state certain efficiency numbers, which could be either theoretical or available only at a steady state kind of a supply. Those things needs to be looked into. So, and look, if I have a component supplier who is just next to me, I can call up anytime. I can get him onto my shop floor and get things rectified. Versus trying to connect and having all kind of a communication language issues. Those are all those challenges also needs to be looked into.
Right.
Thank you.
I have many more questions, but I will go to audience questions first, and if time permits, then more questions. I can already see a lot of raised hands. Imran, we'll start from the first row and then head way back. Ma'am, and then third row.
My question is, we are also doing export of ammonia, and we had a tie-up with the Can you speak on that? How are we trying to create a differentiation here?
Ma'am, could you introduce yourself?
Okay. Yeah, so rightly said, we have a 300 KTPA green ammonia plant coming up in Kandla on our own land. Kandla is also a port announced by the Indian government as green ammonia hub. Yeah, we have been fortunate that Itochu has signed as an off-taker and investing partner. And it's the first phase of the green ammonia plant, and one of the flagship initiatives of the Indian government to start the Indian journey as an export hub for green molecules. It is something which is made possible because we do our own engineering of the plants in Baroda. We make our own electrolyzers, and as L&T, our capital raising capabilities is our credit rating is better than India's sovereign rating. So all of them put together made it possible, and we are also working for this for a lot of time. For 4 years, we're working in green hydrogen. So it's a culmination of all the efforts.
Right. Thank you. Yes, sir.
Good morning, panelists. Thanks for insightful information. It was a fantastic session, and very happy to know about a lot of topics. I'm wondering that India do have several hard-to-abate sectors, and there are many industries which do have waste heat stream. So I'm wondering that how do we see SOEC electrolyzers down the line as latent is available for customers for hard-to-abate sectors. So I'm curious to know about TRL and CRL currently, and how do industry have sentiments on its way forward and focused.
So, can you introduce yourself?
My name is Abhishek Dande from Upper Solutions.
Yeah.
Thank you, Abhijit, for that question. Waste stream is very, very important. And any of these hard-to-abate industries, if you look at steel industry, you look at cement, you look at even the bio-waste industry or food processing, wherever there is waste available and where there is CO2 available, I think solid oxide can do wonderful things. If you just take steel as an industry, DRI is still, a futuristic thing, but even in the blast furnace, they use syngas as a reducing agent. They are currently doing the steam methane reforming process, which is also emitting CO2, and which is again dependent on imports. But if you take a solid oxide and you do a co-electrolysis, you can already produce syngas. The beauty of the syngas produced through a SOEC technology is you can manipulate the hydrogen and carbon content as against CO2 coming from a biogenic route. So here you could, if let's say you're using the syngas for downstream activities like methanol or SAF, you can actually at the source modify what kind of, what is the percentage of hydrogen or CO that is going to be part of the mix. So that makes for a very interesting story, and the circularity quotient. Talking about the TRL level, we are already at TRL 7. PRL wise, we are at about 5.5. I call it product readiness level. So, technology wise, we've built a complete plant in India, 100% built here, and was a very surprising thing for us. that the results that we got on a small plant, which is a 20 kilowatt plant, are equal to what is the textbook definition of what should happen in a SOE. So, built by Indian people, and I think Sanjeev ji also mentioned about skilling. So part of the process that we did while building this was the skilling element. And we could get non-engineers to build a complete SOE plant, which is considered to be, a very difficult plant to build. So the technology is ready. It is just the components. Like I said, the stack components are expensive, and we're localizing that, which will bring down the cost.
Right. Thank you. The next question, a short question and short answer, so that because there are a lot of raised hands. Yes.
My name is Karthik. I'm from Renewable, which is Eco Solutions Consultancy now. My question is to Shekhar. You mentioned that the ministry is meeting all the manufacturers and this discussion is going on. So my understanding is presently there is no import duty because we are setting up the ecosystem. Some components are of course imported, but is the government planning eventually to have some import duty to promote the industry?
Yeah.
Thank you.
So the short answer is site has two streams. One stream is the hydrogen generation, right? And hydrogen generation companies are saying there should be no duty because you need to promote the sector with lowest cost product. And the second section is the electrolyzer makers. We are saying, yes, we will compete with anybody in the world, but the supply chain has to develop. So there has to be maybe a 3-year window. I think, the chance that immediately any duty will come is less because I think the sector is important and the government is looking at what happened to solar. The sector got built with lesser duties, then manufacturing came, and then, the duties came. So while I wish, but I don't see duties coming so fast, especially of the larger nature, like the 15% or 20%, etc. Thanks.
Yes. Any more questions on the right side? Yes. Can you bring the mic to ma'am, please?
Yeah, my name is Deepak. By the way, I'm a scientist. I'm very much out of the field of everybody here. I'm going to ask a very specific question, perhaps to Nikhil or Kowtham, which is how do you see the ecosystem regarding academia, industrial partnership in terms of improving the cost? Everyone has talked about the fact that the tech is developed, but the fact is the tech is not cheap. And the main secret sauce is your catalyst, is your electrolyte, is your diatomic unit. In fact, in academia, which I come from, there are thousands of people working in this, but there seems to be very little crosstalk. Everyone is working in silos, and this does not exist in other parts of the world.
Thank you, ma'am.
That ecosystem.
Yeah, so very nice question at that. So I think one thing which is very good, be it in China or the Europe, is they have a very good industry academia kind of culture where they work together. And the one part is that as an industry, we have a lot of projects to serve, and we have deadlines which were done like a few weeks back. So we really don't have a lot of time to go into developing something very nascent, which could give you an ROI, say, 10 years from now or 20 years from now, which is what the academia is very good at. So when you look at the crosstalk, what we do is we have a lot of problem statements. For example, another issue which I think what even Shekhar sir and Anuj all were telling about is that, the market came very first in solar and production started later, because a lot of capital investment is done in the kind of coating technology you need. Are you sure you want to go for APS? Do you want to do kind of sintering? Do you want to do electroplating? And each of these facilities is super expensive given the size. So you put some technology, you put up a facility, and then later it changes. And then what do you do about it? The same thing about the flow fields. So you, for a large part, it was one kind of a technology, say the mastoid, and then you need one particular dye, and then now everybody is moving to a different technology. So we have a problem statement, which we generally work with a prof, and that is more on the patent side. So for example, we are working on a very different kind of a flow field. So we go through the CFD part, we do a lot of simulations, and we have multiple short stacks. So that is aggressively working on what is going to be the future. But given that and said that, we also have a part which goes into the current projects. So that's how we work, and that's how we're going to get the benefit of having worked with the IITs and the NITs, because the kind of research infrastructure we have is good. And so we give specific problem statements, and see, we work with PhDs who are working on a particular area. We say give half of the, like we work with the current professor, or we pay half of the stipend, and we work together on building IP. So that's how we tackle that problem. Yeah.
Right. Yeah. Thank you. Yes. Yes, please.
My name is Viral Shah. I represent Wiley Consulting. I think my question is in general for the panel. It's around the remaining. So we talked a lot about the electrolyzer stack manufacturing part, but I'm looking at your views on the efforts that are ongoing on the standardization and modularization of the panels of plant as well, which because the ultimate objective is to actually have a zero X for the end user as well. So I see that even in the electrolyzer manufacturing, there is less of how does it integrate, like you deliver this as a one-stop solution? Because as we see that even at a smaller plant, the balance of plant configuration can look much different from the gigawatt scale that maybe some other groups are targeting. So just wanted to know your views and how you see that entire value chain integrating.
Yeah.
I'll just take that. So obviously, the balance of plant, as you call it, as separation skid or purification skid, and even the power conversion side, I would say transformer, rectifier. These are all integral part of the electrolyzer system, and I'm sure all the electrolyzer manufacturers are working on it. But I can speak for Vari what we are doing. So we are working on each of those components, and from our factory we are not only going to give the stack, but also the modularized or skid mounted separation units as well as the purification units are going to come in. And this is something which we are doing to make sure that the site work gets reduced substantially, and you do some kind of interconnecting pipelines and some instrumentation cabling and all of that, but you are ready to go. So this is certainly a very, very focused area, and this is clearly there in the plans.
Right. That will be the second last question, and then we'll end with one final question here. That's all that we have time for.
Very good afternoon to all listening guys. My name is Amit Joshi. I represent Craft Cockerill. So my question is in general to all the panelists. So we have been discussing a lot about infrastructure and capacities, but when it comes to hydrogen safety, that is area of concern what we see considering the nature of hydrogen. So I want to ask if there might be some new regulations or certifications and safety norms which might come into picture in near future, and how it will impact overall green hydrogen projects comparing the current projects we have in the future. And one second small question is like, which are the key sectors, immediate sectors in India where we can see a higher application of hydrogen in this coming 2-3 years?
Yeah, would you like to take the question, Shekhar?
Yeah. So the sectors which are currently using hydrogen, refinery, fertilizer, they are well aware of safety. We are saying we have to have both ways of thinking. Currently, whoever is using hydrogen knows how to use it safely. There are enough standards around it, verification. So there is not a challenge, per se. Yes, when it will go into other sectors, new applications, especially related to transport or wherever people are directly coming near to that, there would be, challenges around that, because you need 500 to 700 bar pressure in the tank, for good volume ratio for a car to have, hydrogen. I think those are the ones which, at least I see it 4-5 years away. Currently, the 6 million ton target for 2030 is clearly from grey to green, which is in fertilizer and refinery. Both these sectors, in fact, there was a talk that there was 0 accident in Indian hydrogen sector so far, maybe 50 years, we are handling. So enough is there. But as the application get into more different things, the standards are coming. Current standards are there. Government is working on, BIS is working on electrolyzer standards, which of course have the safety, especially when they are going to be tested at different factories, what to do. So around that, new standards are coming. Yeah, thanks.
Thanks. Yes, the final question. I know there are many questions, but we'll have to take them offline. We'll end with the final question. Yes. Can you bring the mic to the first row? No, he's bringing it, sir. Thank you.
Thank you. This is Kieran here from Renewable, Germany. First of all, I must say I have a great respect for what you're doing, but I'm not an engineer. First of all, already asked the question for me is management time, the amount of money you spend, the amount of things you spend, and what I learned in my life is do what you are best at. Now, if electrolyzers, top one, 80% market share China has, world class. My German engineers went to Longhi and everyone else, including, I know some of these top executives from Latin and overall, so I'm very close with. I'm asking the question to you. You're talking one brand, I believe the customer likes it, customer doesn't like it. Why don't you continue some brilliant business people? If I can produce the 38 rupees per kilogram ammonia, concentrate on the domestic demand, 1.4 billion people within the and top industries are here. Second thing, you can export to outside India. Germany would love to have your ammonia for $650 per kilogram. Why don't you concentrate on the things you can do best? And everybody looking at it in India. Let the China do what they're doing. You and I all learned in school and college. Do what you best at. If I can save costs, and we are very cost-conscious Indian business people I've met. I'm not saying I'm wrong. My wife is a nationality German discipline. But best of the thing is I'm saying that I hear that there's too much time, too much things is what. Is it because people are many streets saying, oh, we should have made in India everything? Do we have to? If somebody can
Thank you.
with another, why not?
Thank you. Yeah.
I think I take that suggestion from you, and I think if you really look at on eagle eye view or a drone view of where the industry is moving and where the government is also going, that exactly is what is happening. Knowing unknowingly again. There are some people who are passionate about this subject, some people who breathe this, some people who are in the subject because the stock market is making sense with this. There are some people who are, in India we say baju wala gaya, main bhi chala gaya kind of thing. So there are different categories of people here, but we are all culminating towards a single goal. And if you look at this ammonia tenders, I mean, as aggressive as it was, and there's little scary numbers. First time we were able to scare the Chinese with numbers, so that's a good part. But I think those numbers and what we are doing with ammonia will really define things, because with these 750,000 odd metric tons, even if 50% of those projects really come live at the price point that we are talking, we would have disrupted a particular industry. See, the grey ammonia today is at 46, 47 rupees or 48 rupees. So we are, kind of there on a disruption. And we have about 2 or 3 million tons that we import as a country. Looking inwards, and that's what we are all doing, we would definitely speak about exports, this and that, the analysts and the investors like those talks. But really looking internally, we're looking at the domestic market. If we are able to get rid of this entire ammonia story, the entire import of ammonia. Now, the funny part is that we physically import about 2 million tons of ammonia. We produce 15, 16 million or 18 million ton ourselves, but the natural gas required to make that ammonia is 56% imported. So in a way, 10 million tons of ammonia is imported. So that the country is slowly moving, and we will have that specialization built there for sure.
Right. Thank you.
One thing,
Sure.
Kiran, I think it's not just green hydrogen per se. You know, from a government perspective, it's extremely strategic. It is the fuel of the future. So they are looking at it completely differently. You know, one is obviously the energy security, energy independence. You know, so that's the reason for developing the entire value chain. You know, including even electrolyzer manufacturing as well.
Right. Thank you. I know there are many questions and many more things to discuss, but we'll have to close this session now. It has been a fantastic session, and for that, we owe gratitude to Mr. Mathew, Mr. Raj, Mr. Shekhar, Mr. Mayur, Mr. Anuj Sharma, and Mr. Sanjeev Sharma. A big hand for all our panelists today. Thank you. Thank you so much.